Okay, this is an update, and I think it's the last video I will do with this prototype. Okay, this is an improvised prototype for discovering a way to provoke a constant movement using magnets and steels. This is a concept for making a magnet motor. Okay, this represents the whole thing, the whole prototype represents only one unit of a magnet motor. Okay, an example, okay, this is an induction motor rotor. Okay, one unit of, for example, one unit of here will be one spiral coil, aluminum coil, or aluminum, or whatever is there here. There's a lot of one here, making the same effect. Okay, the same thing as this one, but this one represents only one of this one, of this thing. There and here, there's a lot of one. Okay. And this is not a magnet motor. This is a concept to build a magnet motor. Okay. Again, this prototype, I discovered three things. Three things I discovered here. Number one is using shields. There's a shield in the middle. Using shields, that's one. Number two, the spiral magnet, the spiral arrangement, that's number two, that we provoke a movement using the spiral magnet and the shield. And the third thing that I discovered, and recently I discovered, was, in this example, a vertical arrangement of magnet here. This represents one unit. Okay, fixed example, the first thing I discovered, an example of the movement that it produced using spiral magnet. Okay. Using the spiral magnet, they are separated by the gears. Okay. That's the discovery, that movement, using spiral magnet. Okay. That's one. Okay. The other thing was, okay, the spiral magnet here. Okay, the effect of attraction that's gonna create the spiral magnet, if this is the shield, it's gonna feel attracted to the shield, it's gonna move. Okay, what happened? That the same effect is gonna happen in the back side of the spiral magnet. Okay. This is the spiral magnet, it's gonna feel attraction, okay, and then it's gonna feel the same effect, but in the backside of the spiral magnet. Okay. What happened? That to provoke a constant movement, you have to have only a force going in one direction. Okay, let's say that, okay, I wanted to go in this direction, from this side to the back side, like this direction. I want that, but that's the problem, that it's gonna kick back. Yeah, again, without editing. Okay, it's gonna kick back. Let's see. Go front, and then whoop, it kick it back. Okay, that's the obstacle that I found recently, but I had to resolve, and resolving that obstacle, I discovered that I can use then this part of vertical shield and magnets arrangement. This is the vertical arrangement. Okay, it's gonna go. What happened that when the magnet spiral goes in, to prevent that kickback, I'm gonna use then this vertical magnets and I'm gonna create a repulsion. Okay, the first thing that's when it's going in is an attraction. Okay, attraction, and then when kick back, and then to continue the movement, I'm gonna create a repulsion in the back side of the spiral magnet, a repulsion like a push. So the magnet continue in one direction. And that's the thing I resolved here. Okay, let's see an example. Okay, the spiral magnet is gonna go through the shield until this point, until he gets to this point. Okay, until there. Okay, then I take the vertical shield and I'm gonna do this. That's one not too much strong. Look, see? And I'm gonna push the spiral magnet forward. Okay. It goes to that point, and then with this coming in, it's gonna do like that, and it's gonna push. And then repeat. Push. Push. Okay, push. 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 And push. That's a repulsion effect. Push. And push. Because the shield's gonna get magnetized. And it's gonna get a polarity of repulsion. If these magnets are positive, when it passes to the shield, the shield's gonna be negative, right? And then when it passes, this other magnet gonna create the shield positive too, and it's gonna be a repulsion, and it's gonna push the spiral magnet. Well, see? Okay, now this is the part, very important part of this. Okay, with this prototype, this is as far beyond the most far beyond demonstration I can do with the concept with this prototype. First, because of the dimension, this represents 1 unit, is supposedly to, okay, and then why, okay, then comes the question, why with this concept I cannot produce a constant movement in this prototype? Okay, why? Because of the dimension of the diameter of the base, the unit, this is only 1 unit, I need more units of this to provoke a constant movement because it's very big, and because this is an improvised prototype for discovering things, is I do the research. As I do the research, I will do discoveries. And then every time I make a discovery, I have to then adapt that discovery to the concept of producing a magnet motor, a constant movement. So I have to change always. I have to change the prototype. Okay, now this is the final demonstration with this prototype. Now I have to produce a constant movement. I have to do various prototypes because after I make a prototype to demonstrate a constant moving without stopping, that I need a rotor. The next prototype has to be a rotor and a stator. And I need now those materials that I haven't found it because they are difficult to find. But I think that they are water pipes, plastic water pipes from industrial, from the government that have big diameter. I can use that pipes and cut it and use it to build a prototype. To make a prototype to find with this concept a way to provoke a constant movement. It's gonna be. I have the design already. Gonna start. I have the design. Okay, and with that design that I discovered that I resolved the problem of the kickback. Then I wanted to apply it to this prototype to see if I can make this turn. But even with that, I could do nothing. So let's forget about it. And then with that prototype, we using the rotor, big rotor, diameter plastic PVC and the stator. Then after I provoke a constant movement, I have to find a way to develop speed and torque. And then with that, I had to make, I think, another prototype to incorporate it with a self-running generator that I have some designs too of the coil, the magnet, and and then the self-running generator. That is the final chapter of this whole research. Hayan cuerpo calcinado. Yeah, that's the news here in Puerto Rico. My God, every day they kill people here in Puerto Rico. Found a body burned. Wow. Okay, back to you. So that's the story. I have to now change this prototype to another prototype. This is far beyond I can do to demonstrate the concepts of the magnet motor. It's with this thing. Okay. Gonna do some last movement and end it up. Okay. Then going backward. Going backward. Going front. But then we're gonna kick back and it's gonna stop moving because of the opposing force. Well, but then in the other prototype, I incorporate this thing and then I put this thing too, and when it goes that position, I go with the repulsion and push it. Repulsion, push it. Repulsion, push it. Right. Okay, you have to go slowly because this is it's a right. Repulsion slowly. But this is good news. With all these concepts discovered, then I continue the research with another prototype. But I think with this concept, I make the thing move. You have to do the important thing here is doing the design. That's the trick here. You do a good design that favor the concept and it's gonna run. Okay, so this will be the last demonstrate the last video showing using this product. I think I'm done with this. I'm not gonna find anything more to enhance to provoke a movement with this prototype. I don't think so. That's it. But I'm gonna leave it here just in case. In case if I have a new idea and wait a minute, I can make this turn now. But I don't think so. I had to forget about this one and concentrate and looking for the new material for the next prototype. That is gonna have a rotor, a big rotor diameter, plastic PVC plastic, and the stator two more bigger, a little bit bigger, like 1 inch more bigger, and arrange the magnets, small magnets. I'm gonna use small. And the next prototype, for example, the magnets that are spiral is gonna be an example. If this is the magnet, it's gonna be like this, rectangular, large, and then I'm gonna accommodate it like that spiral, a lot of one spiral, or one spiral here, whatever takes me to do the design to provoke that constant movement. Okay, yeah. So that's it. End of the video. Okay, yeah. Yeah, ya, okay. ¿Qué video más agitado este el de hoy?